This is a chapter review of chapter 4. I'm going to try to go through it fairly quickly, so stay alert, pause it where you need to. Hopefully you did this for your homework last week, and this will be a good review for your test. So pretty simple, I think it is anyway. So it says triangle STW. Let me just get a pen here. Let's go with red again. Triangle STW is congruent to what triangle? So you have to get the letters in the same order. So S goes with Q. So we'll use Q, P, R. So just make sure they match up. S goes this way, P goes with the T, and the R goes with the W. Angle R is congruent to what? So sometimes it helps to rewrite and flip them around. So if you just flip it around so that they line up, we can see that R goes with W. I skipped number 2. So triangle PQR would go with what triangle? So the P goes with the T. The next one is Q goes with the S, and the R goes with the W, as we said before. So it would be triangle TSW. And then we would say RP, segment RP, where is RP, goes with, and if we flipped it all around, we could see that it goes with WT. Personally, I would probably rewrite these, like flip them, flip this one. It makes these questions a lot easier. All right, next one. Can you deduce from the given information that the two triangles are congruent? If so, what postulate can you use? So let's just do the first one. Rx is congruent to SW. So mark up your diagrams and then just erase it or copy it into your notebooks. So RW is congruent to SW, RY is congruent to SY. And they share a common side. So this one would be side, side, side. So I'm going to erase this first, and then I'm going to put side, side, side. All right, let's do the next one. RY is congruent to SY. Angle R is congruent to angle S, and we have this common side. Now, this would be side, side angle, so that is not a postulate, so we would have to say no for this one. We cannot deduce it, so we would say no. All right, next one, it says XY bisects RXS. So what that means is it divides it into two congruent angles, like such. And let's see, is that all it says? XY bisects. Oh, it bisects both of them, so it bisects this one down here too, right? RXS, RYS, yeah. So these two triangles, and we can say this one shares a common side, so it would be angle, side, angle for that one. Angle, side, angle. Given RXY is congruent to SXY. And then we're given that Rx is congruent to Sx. Rx, Sx. We have this common side, so we have side, angle, side. So yes, they are congruent. Oops, I did that. Side, angle, side. All right, write proofs in 2-column forms. So let's look at the diagram down here. I guess I will recopy these. I'm just gonna talk these through just because it's hard for me to write on this thing. So let me recopy this diagram over here. Like this-ish. And like that. And like, oh, okay. You guys get the point, right? So here we go. We get M, L, J. All right, let's begin marking it up. Given JM is congruent to LM, and JK is congruent to LK. Forgot the K. Wait, where is the K? Oh, there it is. Okay, JK and LK. So we would put those as our given, and then we would say MK is congruent to MK by reflexive, and then we would say that the triangles are congruent by side, 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 and then we would say angle MJK is congruent to MLK by CPCTC. And that's how we would do that one. Okay, let's do the next one. I'm just going to erase the markings in my triangle because we have to do new markings. And we'll put our K back on there. Okay, this one is given angle JMK. JMK is congruent to one second. JMK is congruent to LMK, and it says that MK is perpendicular to plane L. So this is going to be perpendicular, so we can put perpendicular lines, and then we can say MK is congruent to MK, and so it would be angle, side, angle. We would say these two angles are congruent because right angles are congruent, so it would be angle, side, angle. The triangles are congruent by. And then we would say JK is congruent to LK, and that would be CPCTC. All right, next page. All right, bunch more. I think these will go a little bit faster, although we do have some proofs going on here. Okay. So this one says if angle 3 is congruent to angle 4, which segments must be congruent? So if angle 3 is congruent to angle 4, it means this big triangle is isosceles, so RE is congruent to YE, and that's what we'd put for that one. So we would say RE, whoops, sometimes it doesn't work really well because it's on the internet and it's got a delay. RE is congruent to VE. And that would be because opposite sides of an equal isosceles triangle are congruent. All right, now they're saying that REV is an equilateral triangle, then REV is also an equilateral triangle. Number 13, ES is congruent to ET. ES, ET. Angle 1 is 75, angle 2 is 3x. Well, if these two sides are congruent, then the angles opposite are congruent. So we would say 75 equals 3x, and we would say x equals 25. And then finally, we're saying angle 1 is congruent to angle 2. ES is equal to 3x plus 5. ET, this is the same problem. 25 minus y, then what's y equal? So we're going to do the same thing. We set them equal to each other. 3x, 3y, plus 5 equals 25 minus y. So we get 4y equals 20, y equals 5. Ta-da. Okay, now we have to do proofs. Hold on one second though. Whoops. Oh my text messages popped right up on my screen. Okay, all right, the next one is given GH is perpendicular to HJ, and KJ is perpendicular to HJ. We're also given angles G is congruent to angle K, and we have to prove that the two triangles are congruent. Okay, this is a case. My computer is making a wacky noise, guys. I'm so sorry. I don't know where it's coming from to stop it. Hopefully you can't hear it. Okay, whew. Okay, so let's separate these out. So I'm going to just draw them over here. Oops, I should draw straighter lines, shouldn't I? Sorry, these videos, I'm sure, are super boring. Okay, whoops. Plus my daughter needed a ride right in the middle of this. Okay, to school. They have a 2-hour delay today. All right, so I'm separating these out like such. Okay. I find it so much easier just to separate them out to be able to do these proofs. And I'm just going to talk you through the proofs. So we have G, H, J, and K, J, H. All right, now we'll mark them up. So GH is perpendicular to HJ, which we have right here and right here. And then we have angle G is congruent to angle K. Is that all they give us? Okay, then we know they share this side, HJ. So we know that these two sides are congruent. So we can say that these triangles are congruent by angle, angle, side. And that's your whole proof. So there's really just one step you have to put in. You just have to do this good old reflexive property. It's going to be your friend. So these two triangles are congruent by angle. First, you would have to also say that angle J is congruent to angle H because right angles are congruent. You'd have to put that in your proof because they don't tell you that in the given. They don't tell you that the angles are congruent. They just tell you it's perpendicular. All right, let's do the next one. I'm going to erase all these markings in this one. Okay, so the next proof is GH is perpendicular to HJ. Same thing. KJ is perpendicular to HJ. GJ is congruent to KH. So we have this. Then we also have our reflexive. We have this one is congruent to this one. Now it would be an angle side side, except it's a right triangle. So we can say that they're congruent by hypotenuse leg this time. And they don't want us just to prove the triangles are congruent. They want us to prove that GJ is congruent to KH. GJ, let's see. No, GH is congruent to KJ. So we're going to prove these two triangles are congruent by hypotenuse leg, and then once the two triangles are congruent, then we can say this side is congruent to this side by CP/CTC. These proofs have been really easy, guys, so that's probably how they're going to be on the test. I'm going to write the test next. So, so I wouldn't fear the proofs. You're just trying to find one more part, really, to show that they're congruent. All right, number 17, it says give the reason for each key step in the proof. So they're basically giving us the proof. We just have to come up with the reasons. So we'll mark it up as we go. Someone already wrote in my book. So AX is congruent to CY. So we got this and this. And we have angle A is congruent to angle C, which they already marked. BX is perpendicular to this line, DY is perpendicular to this line, and we're just supposed to prove that AD is parallel to BC. All right, so this is a little bit more complicated proof, but they're giving us all the steps. So the first one is we're proving that these two little triangles are congruent, and we can prove that they're congruent by angle, side, angle. Because this is a right angle and this is a right angle, so right angles are congruent. This is a right angle, so it would be angle, side, angle for this one. Angle, side, angle. And then we're going to say BX is congruent to DY, and that would be CP/CTC. CP/CTC. Then we can say these two triangles are congruent. This would be congruent, right? There would be hypotenuse leg because we have a side-side angle, which is the ASS one, which is not a right one. So, but it is a right triangle, so we have an hypotenuse leg. So this is hypotenuse leg. And then we'd say angle 1 is congruent to angle 2 by CP/CTC. CP/CTC. So we have these congruent. And this is a transversal going through these two lines. So these two lines would be parallel by alternate interior angles. Alternate interior angles. Interior angles. Okay, not so bad, but it would be hard to do on your own. It's kind of a fun proof. It's nice that they gave you so much help. All right, let's go down to, oh, we have a couple more. So we're supposed to refer to triangle DEF to name the following. They want an altitude. Now altitude forms a right angle with a triangle. So the altitude for this one would be DG. forms a right angle, so we would say DG. It comes from the vertex to the opposite side, right angle. A median divides a side into two equal parts. Here's our median, FH. Because it's coming down from a vertex, it's dividing the side into two equal parts. So our median would be FH. Whoops, that F came out funny. All right. Perpendicular bisector of a side of a triangle is a line that's perpendicular and divides a triangle into two congruent parts. So our perpendicular bisector, the only place I see one is KJ because it is perpendicular and it is bisecting the segment into two congruent parts. So it would be KJ. All right, last parts, we just have to name properties. It says point G lies on a perpendicular bisector of EF. I'm going to draw it real quick. Here's EF. We have a perpendicular bisector right here. Perpendicular and it's a bisector, so it has two parts. So it's perpendicular and it bisects. Now I'm going to put the sides on. Hold on. There we go. It's our perpendicular bisector because it's perpendicular and it bisects. Point G lies on the perpendicular bisector. So here's G, lies on it. It says, write a theorem that justifies why GE, so this is E, F, GEGF, hold on, I gotta fix that up a little bit. I gotta put the G in the right place. There's the G. Perpendicular bisector, this is EF. There we go. So we are to, what theorem would say that this is congruent to this? Well, if it's a perpendicular bisector, it means that these triangles are going to be congruent, right? Because of side, angle, side. And then GE is going to be congruent to EF. And the theorem that says that is a point lies on a perpendicular bisector of a segment if and only if the point is equidistant from the endpoints. And because these two triangles are congruent, G is equidistant from the endpoints. So it would say, I'm just looking at the chapter summary, it's number 11. The theorem itself is theorem 4.5. It says if a point lies in the perpendicular bisector of a segment, the point is equidistant from the endpoint of the segment. And theorem 4.6, if a point is equidistant from the endpoint of a segment, then the point lies in the perpendicular bisector of the segment. Okay, and number 20 is very similar. It says ABC and ABD are congruent right triangles with a common hypotenuse AB. So if you want to draw that one, let's see, I did draw this. It would look like this. We have here's our hypotenuse, and it ends up looking like, whoops, just keep writing there. It ends up looking kind of like a square or rectangle. Okay, so we have AB, we have the common side of AB, and this is C, and this is D. So triangle ABC and ABD are congruent right triangles with a common hypotenuse AB. Write a theorem that allows you to conclude that point B lies on the bisector of angle DAC. So they're congruent triangles, so we know that all their parts are congruent, right? So it would look like this, and so these would be congruent. So well, let's see what it's saying. With the common, let's conclude that point B, this is point B, lies on the bisector. So we can tell that it lies on the bisector if it's equidistant from, whoops, I marked these wrong. If it's equidistant from the sides. Hold on a second. So let's do these with 3 and these with 3. So this point lies equidistant from this side and from this side. So these triangles are congruent. So the theorem would be a point lies on the bisector of an angle if and only if the point is equidistant from the side. So these sides I don't think I marked these right. These sides are the same. So they would be the same distance, so it is the angle bisector. So it's a point lies on the bisector of an angle if and only if the point is equidistant from the sides of the angle. So here's the angle, making this a big mess, and this point is equidistant, so therefore it is a perpendicular bisector. All right, that was long and tedious, but hopefully necessary. All right, that's it. Once I can shut this down, sorry.